Normal distribution, probability given. We have seen how to find the probability of an event given the mean mu and standard deviation sigma. Now we shall consider the problem of finding the mean mu and standard deviation sigma if we know something about the probability of the random variable. The concept is as follows. Suppose we have some random variable which follows a bell curve, and we're told that the probability that this random variable is more than some point z, which we don't know, is 20%. Can we find this point z? And the answer is yes. We equivalently say that the probability our random variable is less than some point z is 80%. Because in this form we can look up the table book and look at the answers and find the answer 0.8 and read off the z value and find that z was 0.84. So the concept we're using for these problems is reading the tables backwards. Let's look at an example. The mean height mu of men in Fredonia is 177 centimeters. There are only 5% of men that are taller than 180 centimeters. What is the standard deviation sigma, assuming height follows a normal bell curve? For this problem, we have mu is equal to 177 centimeters. We do not know sigma, the standard deviation. This graph represents what we have. The center is the mean, which is 177 centimeters. Standard deviation is unknown, and the area to the right of 180 centimeters is 0.05, because only 5% of men are taller than 180 centimeters. This is equivalent to saying 95% of men are less than 180 centimeters. Now we transform our graph. As you'll notice, the mean has been transformed to 0, and the standard deviation, whatever it was, is transformed to 1. This always happens when we apply the z transformation. Our point 180 is also transformed. The way we transform is subtract away the mu and divide by the standard deviation, sigma. This is our z point, 180 minus mu over sigma. And this must equal 1.65, because the area to the left of 1.65 in our table book is 0.95. That is, we found 0.95 and read off what the z value was to give such area. The numerator is 3 because mu is 177 and it's just 180 minus 177. Cross multiplying gives us our answer. Standard deviation sigma is approximately 1.82 centimeters. Let's look at another example. The standard deviation sigma of women in Fredonia is 3 centimeters. There are only 5% of women shorter than 165 centimeters. What is the mean height mu of women, assuming height follows a normal bell curve? This graph represents what we have. As you can see, the area to the left of 165 is 0.05, representing 5% of women of height less than 165 centimeters. Standard deviation is 3, and the mean is unknown, which we'll just call mu. Notice that the distance between 165 and mu is mu minus 165. This is important because for these problems, rather than writing the information in a left tail, we prefer to write in a right tail. This is because our table book only gives us values to the right of center, not to the left of center. So we need to transfer this information into a right tail. We are allowed to do this because the graph is symmetric. We go the same distance to the right, which is mu minus 165. So this point is at mu plus mu minus 165. And the area to the right of this tail is 5%. So the area to the left of it is 95%. And we just add our mu's together to make 2 mu. Now we transform into the 0, 1 normal bell curve. The mu is transformed to 0, the standard deviation is transformed to 1, and our point is transformed in the same manner by taking away the mu and dividing by the standard deviation. We're just left with mu minus 165 over standard deviation sigma. So we can conclude the area to the left of mu minus 165 over sigma is 0.95, but sigma is 3. So area to the left of mu minus 165 over 3 is 0.95. That means mu minus 165 over 3 is equal to 1.65, because a z point of 1.65 gives us an area to the left of it of 0.95. A little bit of algebra gives us mu is equal to 3 times 1.65 plus 165, which is 169.95 centimeters. Let's look at one more example. In this example, we need to find the mu and sigma. In Fredonia, there are 5% of children of height less than 100 centimeters, and 10% of children are of height more than 110 centimeters. What is the mean height mu and standard deviation sigma of children in Fredonia, assuming height follows a normal bell curve? I'll not draw the graph for this problem, because it is identical to the previous two, but just in one problem. The area to the right of 110 centimeters is 0.10. So that means equivalently the area to the left of 110 centimeters is 0.90. Now we transform this in the same manner to the 0,1 bell curve. Area to the left of 110 minus mu over sigma is 0.90. That means 110 minus mu over sigma equals 1.28, and this value was got from our table book. A little bit of algebra gives us 1.28 sigma plus mu is equal to 110. Now, using the other piece of information, the area to the left of 100 centimeters is 0.05. Now, the distance between 100 centimeters and the center mu is mu minus 100. We take this point from the left tail and write it in the form of a right tail piece of information. So the same point on the right, symmetrically, will be mu plus mu minus 100. And the area to the right of this point is 0.05. That means the area to the right of 2 mu minus 100 is 0.05. Transform into a 0,1 bell curve, similar manner as seen in previous examples, and we have area to the right of mu minus 100 over sigma is equal to 0.05. In the numerator we had 2 mu minus mu, and we're just left with mu, and dividing by sigma. Equivalently, the area to the left of mu minus 100 over sigma is equal to 0.95. That means mu minus 100 over sigma must equal 1.65, since the table book tells you that if z is 1.65, the area to the left of it is 0.95. A little bit of algebra gives us 1.65 sigma minus mu equal to minus 100. Hence we need to solve the following system. 1.28 sigma plus mu equals 110, and 1.65 sigma minus mu equals minus 100. Add these equations together, and we have 2.93 sigma equals 10. And so sigma is approximately 3.41 centimeters. Sub this back in, and we get mu is approximately 105.63 centimeters. Thank you for watching.